Good morning, everyone. So, today's topic for discussion is about using Hyperledger Fabric for certain applications on blockchain. So, a typical application on Fabric is actually composed of. Let's look into this diagram. So, there's a user interface that is written in JavaScript or HTML, and this will actually interact with the backend chain code. So this is a new term that you're learning. Chain code is nothing but a smart contract or a small program or a specific program written for a specific purpose. So you have a front end and then there's an API which enables an easier communication. There's a chain code, a small program or a smart contract that is written. And based on the information that is given from the user, the contract is executed and some updates are done in the ledger. So this Hyperledger provides various APIs and command line interfaces to enable interaction with the ledger. So you have the ledger here. So this API is actually facilitating where you can have execute certain commands and get to know what is the content in the ledger, what is the account balance, or how many transactions have been happening. So all that. So these APIs include interfaces for what reason? For identity, transaction, chain code, ledger, network, storage, and events. So what is a chain code? We'll see how it is implemented. So chain code is usually written in Golang or Java. And this chain code can be public, which means visible to all in the network, or sometimes you can even keep it confidential. So these code files, they act as a smart contract. And what is a smart contract? The users can give a query, the program executes based on the query, goes to the ledger, fetches the data, and shows the required data. Okay. Users can call such functions in the chain code, which result in state change, and consequently, there might be an update in the ledger. So let us assume I'm just sending an amount of rupees to my friend X. So what happens is, so that gets updated. So it will be made available in the ledger. So there are also functions that are used only to query the ledger. So there might not be any state change at all. So chain code implementation is performed by first creating the chain code interface in the code. And this SIM provides API for accessing all the state variables and transaction context. So as we mentioned, you can write it either in Java or Golang. So what are four functions that are required in order to implement the chain code? The first one is init, the second one is invoke, the third one is query, and the fourth one is for. So this function is invoked when the chain code is deployed onto the ledger. So it will actually initialize. So this initializes the chain code and results in making a state change. So automatically the ledger will get updated. Next is invoke. So whenever any program is executed, when the contract is executed, there are some variables which are taken into consideration. So there will be an initial condition, there will be an ending condition, right? So this function will result in a state change and there will be some writing that will happen in the ledger. The third one is query. So this function is used to query the current state of the deployed chain. Because after I made a transaction, I want to know, has the transaction been made? Is it complete? So I can just make a query. It will not make any change on the ledger, but it will help you to view the content. That's all. So the last function is executed when a peer node deploys its own copy of the chain code. So the chain code is registered with the peer using this function. So these are four important functions. Now let us try to look into all the terms that we've been looking so far. So here we have, so these are the peer nodes, there's a user. Now there are certain services which you've learned, right? So one such is the membership service. So if I want to become a member and I want to myself to be an authorized person, the certification authority should issue my login credentials. So here comes membership service. So what happens? The user will register for the membership service and he is given a certificate with registration by the certificate authority, and now he is going to access the ledgers that are maintained by the peers. At any point of time, now we see that this whole rectangle shows that these are the different blocks with the set of transactions. At any particular time, this is a world state, okay? And this and the நிமிஷத்துல என்ன இருக்கு, the world state. எந்தெந்த லெஜரில் என்னென்ன அக்கௌண்ட் இருக்குது, எவ்வளோ வேல்யூ இருக்குது, இதுக்கு பேர் வேர்ல்ட் ஸ்டேட், ரைட்? ஸோ on the other hand, in case I want to look into some data that is available in this ledger, as we saw, we can make use of this invoice function and we can make use of the query function also. So see here, the user, with the help of the application, okay, he will invoke this function invoice. So this smart contract will take whatever query this person is sending, and then it will try to access the ledger and give the content what he requires. If suppose there is some updation happening, then automatically the state is updated and the updated status also will be visible to the user. So the diagram showed like we had the peers, which means all the nodes at the top which communicate with each other, and every node will have a copy of a blockchain. On the top right corner, we saw the membership service, which validate and authenticate peers on the network by using a certificate authority. At the bottom of the image, we saw a magnified view of the blockchain, whereby existing systems can produce events for the blockchain. And finally, using this invoice method, a user can talk via an application. So all these are the components. Fine. When it comes to this application model, any blockchain application for HyperLedger Fabric will follow an MVC-B architecture. We know what is MVC, model, view, controller. B for blockchain. That's all. So this is based on the popular MVC design pattern, and the components are model, view, control, blockchain. So what is view? This is concerned with the user interface. It could be a desktop, a web application, or a mobile front end, or it could be developing an application where you just have a QR scanner. You just scan to the QR code and you'll be able to see everything. The second one is the control logic, right? So what input am I going to give through the user interface? What is the data model that is maintained? And how is it going to fetch the data, what I need, control logic. The third one is data model. Okay, so depending on the application, you need to decide what data you want, how is it going to be stored. And the fourth one is blockchain logic. So manage the blockchain via the controller and the whole data model in the transaction. So these are the four. So it is view, control, data model, and blockchain logic. Fine. When can you arrive at a consensus on an agreement in a HyperLedger Fabric? So if you want to arrive consensus on an agreement in a HyperLedger Fabric, there are 3 steps. One is transaction endorsement, the second one is ordering, and the third one is validation and commitment. What is meant by transaction endorsement? This process will endorse the transactions by simulating the transaction execution process. Okay, so kickstart, get start. The second one is ordering. Let us assume that there are a lot of transactions that are coming forward, but again it has to be ordered, which should take first, which should take part second, the order, that is very important sequence. So that is ordering service. The third one is validation and commitment. So this process is executed by all the committing peers, whichever node has taken that task of accepting that function, displaying the data, right, validating the transactions. So this process executed by the committing peers, which what do they do? First they validate the transaction which they got from these orderers, and then they commit the transaction. Okay, they commit the transaction, they make the transaction in the block. So I am just receiving an amount of rupees 2000 from a friend. It was one of 100 requests, so it was ordered, and then it comes to a node, it validates, it checks, then it makes that entry into my ledger. 2000 rupees is now added into my account. Fine, this is how consensus is happening. So this transaction life cycle in a HyperLedger Fabric, there are different steps. First is enrolling the user and application, submitting a proposal. Then comes simulation of transaction, and it has to respond back, right? And the next one is submit the transactions to the orderers. So orderer will see how many invoices are coming, and they have to put it in a sequence, 10-1, 10-2, 10-3. So put it in a sequence. And then this order will sort the transaction, assemble the blocks, send to the committer. And what will this committer do? He'll validate the transaction and update the ledger. That's all. So these are the different stages through which a transaction goes forward. A quick look onto this transaction flow architecture. So we have an application or a client who has already registered with the membership service provider, and he has a HyperLedger fabric. So let's go across the steps and we'll follow these numbers. So he invokes or puts a query, right? Proposes a transaction. There's an endorser who will simulate the transaction execution. You run that chain code, that smart contract. Then there'll be a result, right? So he will return that endorsed transaction and it is visible. Okay, it is given to the fabric and it is visible to the client also. And then what happens after it's being visible? Okay, so it's just a confirmation. Did you give this query? Then the transaction is submitted to the orderer. Orderer gets lot of transactions, so he sorts the transactions in the block. Then he will send the transactions. He'll broadcast to all the committers. The committer, any one person, any one node will validate the transaction, make the changes in the ledger, and he'll say, yes, I made the changes, and it is made known to the client, as simple as it is. So who are all involved here? Now we have the application, the user here, the client who's already registered with the membership server. Next comes the fabric or the HyperLedger fabric here. The other elements are endorser. Next comes, he checks, oh, is it a valid transaction or not? He runs a small piece of code, right? And only then he sends to the orderer. Then order will get lot of queries like this. So he arranges it and then he will send that to the committer, the whole set of nodes. This committee, anyone will pick up this, validate the transaction, update the ledger, and give back a notification to the user. So that's all. So this is what is meant by a transaction flow architecture in HyperLedger Fabric. So we just saw through this steps using the diagram. So maybe we'll quickly read through. The transaction proposal is done by the clients. So there's a first step where a transaction is proposed by the client and sent to endorsers or endorsing peers on a distributed ledger network. All the clients need to be enrolled via membership service before they can propose transaction. So whatever transaction was simulated by the endorsers, it generates a read-write set. Okay, how is it done? It is achieved by executing the chain code. But instead of updating the ledger directly, only a read-write set showing what all is to be retrieved, what all is to be updated. That alone is created. So this transaction is sent back to the application. From there, it has to be sent to the orderer. So submission of endorsed transaction read-write sets to the ordering services is done by the application. What will the orderer do? It will collect all the endorsed transactions. It will order it in a particular order, sort it by the channel ID, okay? And then after it sorts by the channel ID, it will start broadcasting to all the committing peers, committers or committing peers. So those nodes will validate the transaction. Once they validate, they will make an update. We've learned this already. And finally, once it is done, it will either give a notification for a success or a failure to the client. Assume that I want to recharge my Netflix account, and this is maintained totally in a decentralized manner. So once I invoke that I want to recharge my account, it first goes and check whether do I really need a recharge. Then it comes back saying yes. Then I say I'll pay an amount of 700 rupees. Then it goes, executes a smart contract and comes back and tells me, are you okay? Can I proceed with it? I give a confirmation. Then that is taken to the orderer, right? And then the orderer sends to the committers. Then the committers make the change in the ledger. So at 10 o'clock, if I had zero balance for my account, at 10:05, I paid an amount to recharge my account that is updated in the ledger. And finally, I get a notification, your account has been recharged. So I told you a very simple example, like how you can develop application, deploy it over a HyperLedger framework, and make it available for the clients. Thank you.